So now you can see that we have both the top and the bottom part. So I've duplicated the bottom part and changed the scale of x and y axis to 0.9. Now what we have to do is to shift the z location a little bit on the z plus direction upwards, and also on the modifier level we're using the bevel modifier as it's the copy of the previous mesh. So we're going to go to the modifiers tab and I'm going to change the bevel amount to 1.5 so it closely matches the bottom line bevel with this one, so it's just on the right place. And we can hide the top part, and we can go to add modifier panel and add a boolean modifier, change it to fast, and select this new cutter to create a new shell out of this bottom part. So we have cutted the bottom ring, and then on the inside we have cut it and created a thickness shell for this bottom part. Now you can see, going close, and you can change the bevel modifier and the stack or the boolean, and you need to make sure that every corner is boolean, which is on the on this thing, and everything you model, all the edges and the corners must have bevel, and it has to have and quite a lot of segments in bevel if you are willing to 3D print this. So the computer has a good amount of geometry to uphold while printing. Now we're going to create a switch and rotor switch, but on the bottom of it, on this bottom part, there have to be a particular cut there to go through. This is where this rotary switch would be fitting down. I've seen that in a lot of microphones, especially in condenser microphones, there's a rotary switch to adjust the volume knobs, and this volume knob bottom has some sort of design and cut, so that is what we're going to create. So I'm bringing that down to minus z axis and moving it down. Now you can do it using the transformations tab, the object tab, and that will be more particular, but I'm just doing this to show you how to do things quickly. But you must be using the object tab to create these transformations to have more accurate levels of precision while working. And I'm going to scale this out, but before that I'm going to add a subdivision surface modifier and make it simple and duplicate it, and this time I'm going to use the Catmull-Clark algorithm to smooth it out, and then I'm going to scale it out on the x-axis so it is sticking out. Now I'm going to add a solidify modifier, so this part is cut it out, as we're going to use this as a cutter. Going to the modifier panel, I'm adding a boolean modifier to the bottom part and using the fast method and in the eyedropper tool and selecting this new cutter. Side it, let's see how it looks. It looks nice, not really bad for this kind of modeling. Obviously it's a tutorial and it doesn't have to be that much accurate on this one. Now I can go more accurate on precision levels, but it's just going to take a lot of time. You can just change the boolean modifier in the stack and can get rid of this kind of jaggedness or geometry distortions that happens while using this kind of boolean workflows, or this kind of things usually can go away if you just change the geometry amount. Now you can use a bevel modifier at the end of these booleans. It's a good thing to do. And you can go to the wireframe mode to see how the booleans are affecting, and especially how the bevels are affecting, to see how much the edges are getting beveled. You can search for shade auto smooth to reduce the amount of distortion that happens for incorrectly calculating the normals, and can get rid of the abnormal problems of the normals. And obviously also always go to the bevel modifier, and harden normals option should be checked in the normals panel in there as well. These two things have to be kept in mind if you're seeing that after doing booleans there is some geometry distortion going on. Let's create a cylinder. This is going to be the volume knob for this microphone. I'm going to make it 5 millimeters in radius, maybe 3 millimeters. No, 4 millimeters looks good. And the depth should be 4 millimeters. And then go to the modifier panel and add a boolean, a bevel modifier. to give it a nice bevel, a good look. Now I can actually go in and model the switch a bit more out, but not for this tutorial. I'm not doing that. It's just already going quite long for just a microphone tutorial, so we can go with this one. And I've added a solidify modifier on the modifier stack and made the thickness of 0.1 millimeter to it. Always add some thickness to the models. It just cannot be a flat thing. It's never 0. It's either 0.1, 0.2, something on those lines. Better if 0.2 or above. For 3D printing, 0.3 is a stable one, 0.5 is a stable one for normal printers. And for high quality printers, you can go down to 0.1 or 2. However, that is not usually that is recommended for normal 3D printing systems. If you're just willing to just 3D print your own mic with your own design, or just for some other reason you're trying to do so, or try making something else. So the things to keep in mind while printing to just keep things right. So I'm just shifting this to -30 and rotating at the z-axis by 90 degrees and pulling it down. Now here you can just eyeball it a little bit, just where it should be, and then obviously use the Y transformation to putting it on the place so it doesn't look out of place. Now obviously there should be something sticking out of the rotary switch that goes inside the mic to make it look more realistic. But if we're just going to have a distant shot, just not too close up on these areas, it doesn't matter that much for a tutorial purpose. But you can do so. You can just go more into it and make the design more outstanding and more realistic. Because this tutorial just already have gone just a bit too long, I'm just not doing that for this one. Now I've selected the bottom part of the mic, going to the edit mode, as selected the cursor onto it, because in the bottom part there have to be an area that is actually used to keep the mic into a stand. For small stands that you just set up on the table, this area is required to lock the mic into those things. So this is that area that needs to be created for that realism. I think it just helps with realism. Just rather than having a top part and bottom part, there is something also just underneath of it that is really similar to what you see in the real world. And obviously when you just try to creating something from the real world, it's better to just make it as it is. If you're just not experimenting and just going for the same type of result, and if you're just trying to make something completely different, then that's up to you what you want to do with it. That's a decision making process. Then what goes in and what goes out, what works and what doesn't. Now I'm changing the vertex count, adding another circle, and change the radius to 10, maybe 8, because this is also going to be touching this part. And yeah, you can make the angle to 0. You have to screw it up to 0.7 Maybe it could be even lesser than that, like 0.5. Yeah, I think the original part that I've seen, it was maybe lesser than 0.5. I think it was 0.3 or 2 on those lines. And now what we're going to do is that after giving thickness to this wire using the screw modifier, we're going to add an array modifier to it. Go always to the constant offset rather than going to the relative offset. The relative offset actually doesn't works well. For accuracy purpose, constant offset is always better to go for. Always remember, while using this workflow, relative offset is not great for this particular workflow. And I've added a solidify modifier from modifier stack, and always put it above the array modifier, so all the arrays doesn't have to count after arraying it. It doesn't have to count the solidify modifier. You can always count the solidify modifier beforehand and then array it to other meshes. It just helps to calculate the model in a more faster way. And add a bevel modifier to have more profound edges, and always check the hard normals option in the bevel modifier normal stack, and change the constant offset to 0.7. And then we're going to add 8 arrays of this, 8 copies of this ring, so it just looks right. I think there's like more than 8 copies on the original model, but I think this one also works. And always check the shade auto smooth option, and there was a cut inside in the bottom part of this area, which was rounded on the corners and looked like chamfered quite. So we're going to create a plane for this, and we're going to scale it on the x-axis. Now the size, you have to determine what is going to look good. What could be the actual size of it? I'm just going and eyeballing it for this purpose right now. And always use vertices if you're just using a single plane with no thickness. And adjust the beveling amount. It's going to be round, so it's going to look like this. 1 for full round is what I saw the shape was like in the real world microphone, and the segment was 10. And add a solidify modifier to it. And make sure it just goes through the mesh. So it goes throughout the thickness of the mesh, and so it would make a hole through out of it. Select this mesh and add a boolean modifier going to the modifier stack, and pick the side over tool and use this new cutter to cut the object. And move it to the cutters. And go to generate a new bevel on the mesh, going to the modifier stack, and always check the hard and normal options, so there would be less problems calculating the geometry. Normals are calculated properly and no geometry distortion happens. Usually after beveling, more geometry distortion sometimes happens, not just for not checking this option. can also shade auto smooth this as well. Now there is some sort of problem that happened with this. I think that happened because while I used the boolean, I actually didn't check the fast option, and rather than that I've just checked on the exact option, and that sometimes messes up with the geometry. If you're just cutting in the thickness, it just sometimes sticks to it. So it's good to know that sometimes you can just get into problems and see that which option you have checked is wrong. When you just go more into this workflow and keep practicing onto different things, you just get to know that where you might have just done the wrong action. So next time you would not be making that action. This not I've done purposefully on this video, just happened on its own. Just later on discovered that might be the boolean option that was the problem. I just didn't check the fast options. Sometimes checking between the exact and the fast option makes the difference in the cutting. Sometimes the distortion goes away with the fast, sometimes the distortion happens due to the fast, and this kind of things happen. So you need to check which method the object is properly being able to cut the other, which algorithm is just more preferable for the shape you're trying to cutting into. The other normal options are checked. The clamp overlap must be unchecked, so all the areas could be built. Now you see this new area that we have cut it, there are some distortions going on, and that can also happen due to having less amount of geometry or too much of intersected geometries going all together and creating distortions. In this scenario, because we have this procedural workflow, we can change the amount of segments to actually make sure that after changing to how much this goes. So after changing it from 10 to 6, it goes, because the intersection change the geometries. The geometries that we have used, that changes, and that's why the intersection also goes away. So this is the workflow that I'm just talking about. It's procedural, it's non-destructive, it has its own things, but when you just get into it, it doesn't have to make a small amount of wrong step and just have to redo the whole thing. You just can go back and just turn it off or cut it out and just add a new cutter into it, and just works. And you can just make 3 different iterations of one design, 5 iterations of one design, and goes so on with it. Just divide it into folders, sometimes use collections, sometimes this and that, and this will help you to just be more iterative into things. You can iterate designs, concepts over and over with the same mesh with different ideas without really touching the mesh on a very destructive level and just keeping it on a primitive level. So you're just gonna go back into it. Now you see we have the top part and we have also the bottom part. Together it looks well. It could be that the design could actually be a lot more profound in its look, but I actually didn't have the time to just make that so, because this one design just took a bit more than an hour to design and doesn't want to intimidate a new beginner on this level. I just wanted to make it a beginner friendly tutorial, and I'm just adding a few materials, simple materials to it. One material for the grill and one material for the whole plastic body of the mic. I think it's not plastic, it's carbon fiber whatsoever. And also go to geometry nodes. Here we have to add the set material node in order to make the material work. As we have made the grill out of the geometry nodes, the material also have to go through here, so it will be calculated by the software. And now you can see I'm going to change the roughness of this plastic.